So this section today is going to look at cholinergic pharmacology, and we're going to examine various actions of acetylcholine. Okay, learning objectives. There's several. This is a pretty large file to go through, so spend some time on these topics. I want to do a brief multidisciplinary kind of overview. And just to kind of remind you, we're looking again at the nervous system. We're going to be looking really on the orange boxes over here on the right, these the parasympathetic nervous system, or the PNS, sometimes called the cholinergic system. And when stimulated, basically you're looking at the digestive type properties. So we're looking at salivation, digestion, moving fluids and solids through the GI and the GU system, as well as a reduction in heart activity. And we'll spend a few moments on that when we get to that specific point. And so just remember that in terms of the parasympathetic nervous system, we're kind of dealing with, really long preganglionic fibers and relatively short postganglionic fibers, both of which have the ability to secrete acetylcholine, and that's going to be our primary focus in terms of neurotransmitters for this talk. But what I do want you to focus on is the fact that these that acetylcholine can bind to two specific receptor subtypes: the nicotinic receptor subtypes, which are more often found on the ganglion, and then the muscarinic receptor subtypes, and there are several, which we typically associate with some of the effector type processes. You see muscarinic receptors in different anatomic compartments, mostly muscles and so forth, and secretory glands and so forth. And so we'll spend some time talking about what that means from a pharmacologic standpoint when you agonize and then when you antagonize them. And so just to kind of briefly look at some of the biochemistry behind some of these cholinergic nerves, we're looking at the synthesis of choline combined with acetyl coenzyme A to produce acetylcholine. And that occurs with this enzyme called CHAT, or choline acetyltransferase. Okay. And then, of course, these choline molecules are kind of put into storage vesicles, and basically elevated calcium levels cause these storage vesicles to kind of dock or fuse with the plasma membrane. And then based on their interaction with the specific proteins, which are listed here, you can see the release of acetylcholine within the synapse. All right, and this is basically depicting what I showed you. And there's a few drug targets here that can interfere with the synthesis and some of the biochemistry of acetylcholine. We're not going to really talk a lot about these types of drugs. We're going to really focus on the drugs that have profound effects within this synapse right here. And so these drugs would either potentiate or antagonize the effects of acetylcholine on either nicotinic or muscarinic receptors postsynaptically. Okay. One thing I do want to draw your attention to is this acetylcholinesterase enzyme that exists within this synapse, which would obviously degrade acetylcholine, breaking it down into its building block components. And so a lot of these are drug targets, but we're really going to focus specifically on the nicotinic and the muscarinic receptors. And of course, these receptors were named because our great ancestors were walking around the savannas and the jungles and so forth, and they were eating and later smoking random things. So the muscarinic receptors were discovered upon ingestion of mushrooms of the genus Amantia, and then the muscarine molecule was of course later extracted and synthesized from that. And so the muscarine receptors, and there are 5 of them, these are G protein coupled receptors, and so they have a very similar kind of cell signaling physiology that we've talked about in detail in other courses. And of course, the nicotinic receptors were named because of the effects of nicotine. Of course, this is tobacco right here. And of course, there are 2 subtypes, the nicotinic sub M and the nicotinic sub N, as in Nancy. And these are voltage-gated ion channels. And so just to kind of review, here's what the G protein coupled receptor looks like. Sometimes you can hear people referring to them as a serpentine or serpentine molecule. And so this is a 7-transmembrane type protein that goes through the plasma membrane. And then this third intracellular loop is the one that's more biologically active. And these are the ones that are these are the G proteins that are coupled to that loop. And of course, your nicotinic receptors are your ligand-gated ion channels, and of course, that ligand could be acetylcholine, could also be nicotine. Okay, and then of course now we've got all these different ways in which we can get nicotine. There's the old-fashioned way, the hookah, the cigarettes, and I didn't put cigars on here, but now we've got e-cigarettes. Everything is becoming electronic, even our cigarettes. And so we'll kind of table the actions of nicotine specifically. We're really going to focus on some specific subtypes that you'll see that are more kind of disease appropriate for this particular block. The NN is associated with the nicotinic receptor that's associated with nerves or at the ganglion. It's got the subscript N. And then the nicotinic receptor that's associated with muscle movement, so like voluntary skeletal muscle movement, would be the nicotinic sub-M receptor, and sometimes you can see it classified as the neuromuscular junction receptor or the NMJ. All right, and so the muscarinic receptors can be introduced here. Let's take a break and let's have a separate recording for the muscarinic receptors because I do want to spend some time on this.